A particle is travelling in a straight line. After 2 seconds, the velocity is -2 meters per second, and the particle is 3 meters in the negative direction from some origin O. The acceleration a meters per second of the particle after t seconds is given by the equation a of t is equal to 2. So that means that it's experiencing a constant acceleration of 2 meters per second throughout the entire journey of this particle. For part A, we're asked to determine the expression for the velocity of the particle v of t. So we need to remember that v of t is equal to the antiderivative of the acceleration rule, and that's with respect to t. So that means that v of t is equal to the antiderivative of 2 with respect to t, and when we antidifferentiate a constant term, we simply get 2t. So we introduce the variable that we're anti-differentiating with respect to, and then we get plus c, where the constant c is an element of the real number set. So to complete this problem, we need to take into consideration that we know the velocity at a particular time in this question. So v, when t is 2, is equal to -2. Therefore, we can set up the equation v of 2, which is 2 times 2 plus c, is equal to -2. Therefore, 4 plus c is equal to -2, which gives c is equal to -6. So to finish off this part of the problem, we can say that the velocity of the particle v of t is equal to 2t subtract 6. For part B, we're asked to determine the expression for the position of the particle x of t. And we need to remember that x of t, the position of the particle, is equal to the antiderivative of the velocity rule, and that's with respect to t. Therefore, our position is x of t is equal to the integral of 2t minus 6 dt, and when we antidifferentiate that, we get 2t, and we add 1 to the power and divide by the new power, minus 6, and because that's a constant, we introduce the variable t, and then once again we get plus c, where c is an element of the real number set. So to find this plus c and then find the unique rule defining the position of this particle, we need to remember that we have information about where the particle is, so it's 3 meters in the negative direction from some origin, at the 2 second mark. So that means that x of 2 is equal to -3, and that's because it's in the negative direction. Therefore, we can set up the equation, and 2t squared over 2 is just t squared, so we have 2 squared minus 6 times 2 plus c is equal to -3. Therefore, we find that 4 minus 12 plus c is equal to -3. Therefore, we find, once we've solved that c is equal to 5. Therefore, we can wrap up this question by stating that the position x of t of this particle is given by just t squared minus 6t plus 5. For part C, we're told to hence or otherwise determine the position of the particle when the particle is stationary. And we know that the particle will be stationary when the velocity v of t is equal to 0. So from before, that means we want to solve v of t, which is 2t minus 6 is equal to 0. And if you solve that, we find that t is equal to 3 is when we have a stationary point on the curve. So we know that the stationary point is at t equals 3, so the position at 3 we can write as x of 3 is equal to 3 squared minus 6 times 3 plus 5, which gives 9 minus 18 plus 5, and that is equal to -4. So the interpretation of that is that it is 4 meters in the negative direction.